Today we're going to look at starting to figure out feeds and speeds for the CNC router. As you could probably guess, on our router we have to very carefully control how quickly our router bit moves through the material that we're cutting. And the material that we're cutting matters a lot, and the router bit matters a lot. The project that we're going to use to do this is going to be a 12 by 12 wooden letter, just a single letter. And we're going to talk about the different kind of router bits that we can use to make this letter. The short end of it is we're going to be using this, and you probably can't see it super well because the video is tiny, but this is called a corncob bit. And if we look at the flutes, they are bumpy, kind of like a corncob would look. It's not a straight router bit at all. So it's a little bit different and it's expensive. I'll show you how much it costs on the website. But to start this project, we are going to need to open up Vcarve Pro. Again, I'm using version 10.5. It may update in the future, I don't know, but they all work kind of the same. And we're going to create a new file. The job size is going to be 12 by 12. Thickness is 0.75. We're going to go material surface for our Z0 position. And we're going to start from the center. And then I'm going to say OK. Now you got to pick a letter. I don't care what letter it is. I don't care what it means. I am going to pick the letter, I'm going to do the letter P because it's got this middle cutout that I want to make sure you guys are clear on. But if I was doing an S or something like that, it would be very similar. We just don't have this middle cutout. So I'm going to do the letter P, and you can pick the font that you want, but generally speaking, the more blocky the font is, the easier it is to do all this tool pathing. You can make the text height, you can adjust it here if you want. I'm going to go, I would say at least 10 inches with your text height. Don't go all the way to the edge because we have to fasten this down to the router, and we need to have a little bit of extra room to do that. So I'm going to say close, and then I want to center this. To center it, we want to click on under Edit Objects, this one right here called Transform Mode. You can see when I click on that, I get handles on my router, or not on my router, on the letter, and that allows me to move it around. And I'm going to put it right in the center, so I can find that center dot and put it right in the middle of the page. Now, if it's not exactly centered, we're going to be just fine. So this is really it. We're not getting too deep into Vcarve or how to use Vcarve. We want to focus more on how to calculate the feed and the speed rate. So with this selected, if it's not selected, I can still do this, but it's going to be better for this to be selected, purple. I'm going to come up here and select tool paths. Now, throughout class, we're going to use all different tool paths. The three we're going to use most are a profile, a pocket, or a drilling tool path. The profile tool path takes the router and it traces the lines that we have. That's going to be a really common one when we're making signs. Pocket toolpath finds two lines and cuts them out. So if I did the pocket toolpath, it would recess the P. The P would be cut out into my board, and sometimes that's what we want. A lot of signs are cut that way. But we're going to do a profile toolpath today, and we're going to start at the top and work our way down through the list. So all of our solid wood that we have is 3/4 of an inch thick. So our start depth is 0, always 0. For every project that we're doing is 0. The cut depth is going to be all the way through. On some projects we're not going to want to cut all the way through. If we were doing that pocket toolpath, we may just want to make a recess, but we're going to cut all the way through. Our board being 3/4 of an inch thick, we're going to cut in to the spoil board 5/1000ths of an inch. Now here in Vcarve, it helps us a little bit, but we are going to have to make a new tool. So to do that, I'm going to come down here and click Add a Tool, and then it automatically defaults to the last tool that we made. I'm going to edit this. We're going to call it an end mill. I'm going to call it a corncob because that's what most people call it. Our corncob bit, well, we'll do this. It's technically an end mill. 0.375 is the right diameter. If you have a different number in there, please make it 0.375. And then in the parentheses over here, I'm going to call it the corn cob bit. Then I'm going to say OK. If I want to put notes in here, I can. And we'll talk at a different time more in depth about why this corncob bit, sometimes it's called a chip breaker. Solid wood is really hard to cut. It's hard, it's solid, it's not like plywood or particle board that cuts pretty easily. What we want to do is be able to break the chips up. Solid wood tends to have kind of big curly chips, and that heats up the router tip. So we want to make sure that we break that, and so the corncob bit does a good job of breaking that up. So it generally is, or the tool type is an end mill, units are inches. This is where we have to enter the diameters 0.375, whoops, not 0.375. And the number of flutes is 3. So I'll hold this up to the camera and look at it, but if you see, it's got 1, 2, 3 flutes. You can get these in 2 or 3 flute designs, so we're going to say 3 flutes. Now when we're creating the settings here, the number of flutes matters. What we're trying to do is create a cool cutter head. If our cutter head is moving too quickly or too slowly, it generates a lot of heat, which wears out these tools really quickly. And if we, well, I got to do this, and I'll show you how much this costs. But this bit's like $95, so we want it to last as long as it possibly can. I am going to need to use, anyhow, the pass depth for this. I am going to be using this chart, and I'm going to pull it up here. And it may not allow, well, I'm going to close this for a second because I didn't open up. It won't let me navigate away from this. On our homepage on Canvas, there is a feeds and speeds bit chart that I want you to use, and you're going to use this solid carbide roughing corncob for solid wood. So when we look at this, I'll zoom in so hopefully it's a little easier to read. This is from the tool manufacturer, Amana Tool. It tells us some information that we need to know about how to use this bit. So the bit that we're using is this one right here. It's 3/8 of an inch in diameter. We're going to be cutting solid wood. So this thing says chip load per tooth. The number, all we need to know is that when we punch this into Vcarve, we need to land somewhere between 13 thousandths and 15 thousandths of an inch. So here is the calculations that we're going to be using. So our operating RPMs are 18,000, and Vcarve is going to help us with this. So I'm going to see if I can get these two to open up at the same time, because sometimes Vcarve doesn't like to play nice with other programs. So let's do this and have this up at the same time. You probably don't have to do this, but I am going to try to get my face out of the way. So let's go select the tool. So if mine's saved from when we were doing that before, but it didn't save all these notes. The diameter 0.375. The number of flutes we said was 3, and now we're going to create the settings. So the pass depth, if I look at this chart, oftentimes it will say 1 times D. D is the diameter of the cutter head. So if it's 3/8 of an inch, it means the maximum pass that we can make is 0.375. We can't cut any deeper in one pass than the width of the tool. So step over, that's a little bit more up to you. Step over means that if we have to make 2 passes that are next to each other, this is how much they overlap. So this is saying they're going to overlap 40%. If we were doing a massive sign, like going on the side of a massive building, we could have that step over be less because it'll really reduce the number of passes. We're just going to leave it at 40% right now. That's not really going to apply too much for this project. Okay, now we need to get to spindle speed. So this says operating RPM is 18,000, so it likes spinning at 18,000. Now feed units at inches a minute. That is what we're going here. Surface feet a minute. We got that. That is surface feet a minute. To find feed rate, that's inches per minute. It's RPM times number of flutes times chip load. This is where if we had to get out a calculator and calculate this, we can. But our chip load right here, we can kind of play around with the feed rate and to get to the chip load of 15 thousandths. Right now we're at 33 thousandths. So if we want the chip load to be higher, let's see what happens if we increase the feed rate. This is how quickly the router moves through the router bit. So if we increase the feed rate, that chip load gets smaller because we're moving faster. Going too slow creates too much heat. So the way that we can mess with this is we can slow down the RPMs. So if I slow down the RPMs, you see that chip load gets smaller. We really don't want to feed, I don't like feeding this through at 200 inches a minute. I like 150. So to get this down to where it needs to go, let's slow it down to 14,000. We're getting closer, but I don't want to go to 7,000. Yeah, that's just getting too slow. So we're going to go 16,000 and let's speed this up. Whew, we're having a hard time getting there. So let's come back over here. I'm going to get this back to 18,000. I wonder how fast we'd have to go. Okay, so that's going the wrong way. Let's go down to 100. So we're getting closer. Let's go to 90. 90 is almost there. So at 80. All right. So what I had to do was go the wrong way. I just screwed that up, but I'm really good at making mistakes, and you guys are going to see that. So our feed rate needs to slow way down if we are going to get to that right chip load. And the plunge rate is how quickly this moves down into the machine. I don't know which CNC router you're going to be using. You're going to be using one of the Laguna machines for this. I'll probably try to split you guys up. Just know that if you're using the big Laguna machine, the full-size CNC, this tool number is probably going to be tool number 4. If we're using the IQ, the smaller one, that tool number is going to be number 1. I'm going to put this up to number 4 because I think I'm going to try to get most of you using the big CNC router, but that's important to know beforehand, but we can always come back and change this later. So now that I got this set, I'm going to say apply, and that's going to lock in these settings every time I use this tool. And we can change it. When we change it, we'll hit apply again. So then we'll say select. So this thing automatically is telling me now, we can get back to maximizing this. This calculated that we need to do two passes because we can do about 3/8 of an inch as a max pass. We're doing 3/4 of an inch as depth, so technically we should be doing 3, but the machine lets us cheat it to 2, which is fine. All right, now we got to decide what vectors are we going to cut. This is the yellow is the tool path, and I want to cut around the outside of my letter. So outside of the letter P. That's good. Now the next thing we got to do is, this is super important, we have to always add a ramp. We'll talk about this in class, but remember, the bottom of this tool is flat. It's not like a drill bit that can go straight down into our material. It has to come at an angle into our material. It can't go straight down. A ramp of 1 inch is fine, and then we're going to call this outside P. You can call whatever you want, and then I'm going to hit calculate. This is going to give me a warning that just know we're going to cut through your material. We're going to say OK. So now we are going to cut on the outside of our letter P, and you can kind of see there's 2 lines here. If I click and hold this, we can rotate it, and we can see that each of these blue lines is a tool path. It's going to be making 2 passes because it's going to do 3/8 of an inch, then come back and do another 3/8 of an inch to get all the way through. Also, this red mark, that is just where it traverses at the safe level. So that's not cutting. It means it's going to cut the outside, and then after it's cut the outside, it's going to move and cut the inside. Now here's the problem that we're going to have, and it wouldn't be a big deal on this project, but because I said that the tool path should cut on the outside of the P, it's also going to cut on the outside of this, which isn't a big deal with this font, but other fonts it may make a difference. So actually what we're going to do is I'm actually going to delete this, and you wouldn't have to do this. If you were doing an S or a T or an H that doesn't have the little circle in the middle, you wouldn't have to worry about it, but I click delete and it disappears. But don't worry, that was just a 3D view. I'm going to come back to the 2D view, and you can see it selecting this at the same time. I'm going to right click and say whoops, convert to curves. Now these two are separate because I'm going to do, and the cool thing about all of this is I'll come back here to the profile toolpath and all of those settings are saved. Going on the outside, it's got the corncob bit. The only thing you sometimes have to add back is the ramps, and we'll call this calculate. Get the arrows cutting through. So now it's just cutting the outside. Come back here to the 2D view, and now I'm going to do a separate tool path. I'll just close this, and everything is going to stay the same, but I'm going to go inside. So I want to cut inside of this, not the outside. Again, this project, it wouldn't be that big a deal if we cut the outside. I'll add the ramp back. I'm going to call it inside P and hit calculate and say OK. So there, now we're going to be right. Remember this though, this might look small, but it is accurate. And again, the fonts will all look different. What I like to do before I'm all done with this is I will say preview all toolpaths. And when I say preview all toolpaths, it's going to show me what's going to happen. Now, the last thing that I wanted to talk about is adding tabs. So we'll have a problem here if we use either one of our routers, as hopefully we'll talk about. Some of our routers have vacuum tables that hold things down, but solid wood doesn't get held down super great by a vacuum table. It's too porous. So we're likely going to either clamp or screw down the back piece into the spoil board. The problem is going to be when we cut this out, this piece is going to move right at the very end, and that's going to be a problem because it could break the router bit, or it could go flying across the room, or more likely it's going to take a little nick out of here. So what I'm going to do is I'm going to come back to my outside P toolpath, and I am going to say let's add some tabs. We're going to make the tabs pretty thin at, I'm even go 0.0625. So that is a 1/16 of an inch thick, and I'm going to put 3 tabs on here. We want to say avoid corners and curved regions and say add tabs. So what that's going to do, and you'll see when I preview this, it's going to leave just a little tiny bit of wood there to hold everything in place. And I can edit where I want these, so I can slide that down if I don't like where it's at. Generally speaking, we try to avoid curves and things. This one's going to be in a pretty easy spot. We'll also, so we'll come down here, oops, sorry, and click close. And then we're going to hit calculate, and that will update it. So it doesn't look like it added in the 3D view, but I have to hit reset preview. Preview all visible toolpaths. You see it leaves these little tiny tabs there to hold it in place. And I should do the same thing for the inside of that P. So I'll come back inside P, add tabs, edit tabs. I'm only going to do 2. It's not that big a deal. We'll say add, close, calculate, and then reset preview, preview all toolpaths. So we got those little tiny tabs in there, and that's just going to keep everything together as we're cutting out our big letter. All right, I think we're done here. So we're going to close the preview box, highlight the toolpath, and then we're going to say save. Now is when you need to know which router you're using. It actually could be any one of these 3, the Shark, IQ, or Smart Shop M. I'm going to do this for the Smart Shop N, and then I'm going to say save toolpath. Now this is where you would save the toolpath onto the flash drive that's been assigned to you. I'm going to put it in my download doc, in my downloads on my computer, and I'm going to call it Swenson P, your last name, and then the file, so this is a file P. Then I'm going to save. Now, this is when we get into the double check. So the partner that you're working with on this project, I want you to open up this file with that partner. First is click here on Job Setup. I want you to verify this for your partner's project. You're on the material surface, you're starting in the middle. That's all you got to do for that part. And then you also need to go to your thing, the recent file that you just downloaded, open this up, and now we got to remember what our Z heights should be. So we are starting on the top of our project and we're cutting down 3/4 of an inch. Remember, this could be metric. It's okay if it is metric, especially if you're using the Laguna machines, which we probably will for this. So we're thinking Z heights of about 19 millimeters is about 3/4 of an inch. So I'm going to say edit, find next, and if we find any Z's that are more than like a negative 19.05 or 20, we have a problem. So I'm going to say find next, so that Z is a very small negative, very small negative. Z is 17, Z is negative 19, negative 19, 8.03, negative 2 millimeters. And you can do this for yourself or you can do this for your partner. Either way, we're going to be in good shape. All right, so I've got no crazy deep negative Z values. So now I can go cut this out on the machine. Now to turn this in for a grade, what I want you to do is I want you to get in the 3D view, close this, and we're going to get to the preview tool path. And we're going to preview all tool paths so it looks just like this. Then I want you to, let's see if we can export PDF, the default sheet. We're going to say export, save it on your network drive. I'm going to put it in downloads. I'll call it the same thing, Swenson P. Save it, and then when I open this up, this is what will show up, and that's what I want you to submit, is this. So that coupled with the actual wood thing that you turn out will let me know that you did this assignment on Canvas. So you'll submit that exported PDF, and that's how we'll do it. If you have any questions, please find me.